My dear students, today we will discuss few more concepts related to second module. That is, in second module, the last concept is about differential and difference equation representation. Here we'll study about how we will solve about the difference equations that we'll study in the second module. This is the last concept in the second module, that is about differential and difference equation representation. Here you see the constant coefficient differential equation is given as the differential equation constant coefficient equation is given as summation of k equal to 0 to n ak d raised to k dt raised to k yt equal to summation of k0 yeah, k summation of limits k is equal to 0 to m bk d raised to k dt raised to k x of t. This is the representation of differential equation. Similarly, we can represent the constant coefficient difference equation. This is difference equation is given as summation k equal to 0 to n ak y of n minus k equal to summation k is equal to 0 to m bk x of n minus k. This is about the difference equation. This is about the above one is the differential equation. Now how we will solve that, and how we will solve those equations, that is solution of differential equations. That is, consider the differential equation that is which we have mentioned in the above equation. That is nothing but summation k equal to 0 raised to k equal to summation of k equal to 0 to n ak d raised to k dt raised to k into yt equal to summation of k is equal to 0 to m bk d raised to k divided by dt raised to k x of t. Here the solution of the differential equation has two components. Suppose we want to solve this equation, then the solution of this differential equation has two components. That is, one is what? The natural response. We can call it as also zero input response. Second one is forced response or zero state response. Then what is it is having solution is having natural response and forced response. The complete response is nothing but addition of sum of this natural response. Here they have given. First we'll analyze what is natural response or zero input response. This is the output produced by the system only due to here this is the output produced by the system only due to the initial condition. It is due to initial conditions, and here we will take input as 0. Input is 0 for natural response. Hence it is also called zero input response. It is denoted by y of raised to n t. This is here we will consider input as 0, but here we will consider initial conditions of the differential equation. Then what is forced response? It is also called as zero state response. That is, in forced response, here this is the output produced by the system only due to input. Here we will consider the input and will not here will initial conditions are considered 0 here for forced response. Here we will consider input as 0 and we will consider initial response, initial inputs, whereas in initial conditions here, but in forced response will consider the input, but initial conditions were considered as 0 for forced response. Within program will analyze problem will analyze, we will come to know how we will solve the problem, how we will find out what its natural response, how we will find out the forced response. It is denoted by y raised to f. F stands for forced response. Here N for natural, N stands for natural response. Then the complete response of the system is equal to the sum of natural response and force response. The sum of these two responses, natural response and force response, is nothing but the complete response of a particular differential equation. Therefore, the complete response of the system is equal to sum of natural response and force response. Thus, initial conditions as well as input both are considered for complete response. Here, therefore, in complete response, we will consider as if we will consider the input also and the initial conditions, because this complete response, this is nothing but the combination of natural response and as well as force response. Now we'll analyze what is natural response. Natural response is denoted by y raised to n of t. This is the natural response. The output of the natural response is denoted by y raised to n t. For example, for natural response only, initial conditions are considered and input is 0. Here in equation 3.23, this equation, here in this equation 3.2.3, in this equation, you see here, this will consider as summation k equal to 0 to n ak d raised to k dt raised to k y of t equal to 0. Here, but this is equation is what? Summation of k equal to 0 to n ak d raised to k dt raised to k y of t equal to summation of k equal to 0 to m bk d raised to k dt raised to k x of t. Here x of t is the input. This we will consider as 0 here while finding the natural response. Therefore, when we consider this as 0, here this whole term becomes 0. Why? Because this input is 0. We go on making the summation, finding the result. The ultimate result will be 0 only. Therefore, here to finding the natural response, we will consider input as 0. Input is 0. Therefore, this equation becomes as like this. That is summation of k equal to 0 to n ak d raised to k dt raised to k y of t equal to 0. This is called homogeneous differential equation. This is called as homogeneous differential equation. Then the natural response of the system is of the following form. That is y raised to n t equal to it is of the form of summation of I equal to 1 raised to n ci e raised to r it. This is of the form. This equation we will write in the form as like this. Some standard form we will write this one. Here ri and n are the roots of the system roots of the system's characteristic equation, which is given as summation k equal to 0 to n ak r raised to k equal to 0. Putting the roots ci of above equation in the equation 3.25, here in this equation, suppose we substitute, we get the natural response. That is how we'll find out the natural response. That we will discuss with an example. We will discuss how we'll find out the natural response of a particular differential equation. Suppose we'll consider an example. That is, determine the natural response of the system described by the differential equation. Here we'll find out that what is its natural response. The differential equation is 10 raised to 10 into dy of t dt plus 2y of t equal to x of t with y is equal to y of 0 equal to 2. Therefore, what's its the natural response? The natural response is obtained with 0 input. Hence, the homogeneous differential equation becomes, that is 10 into dy of t dt plus 2y of t equal to 0. Because while finding the natural response, we have to consider the input as 0. Therefore, here this is same as the here in place of x of t, we'll place 0, because we are finding while natural response we will consider input as a 0. Then what is the first step? Now, to obtain the roots of the characteristic equation from equation 3.2.6, we can obtain the characteristic equation as from 3.2.6 here 3.2.6 will obtain the characteristic. We have to use this equation. From this equation we'll get the roots of the characteristic equation. That is this here we can write as summation k equal to 0. Here what? K equal to 0 to n ak r raised to k equal to 0. But here we have taken that is summation of k equal to 1, because n is nothing but the order of the differential equation. Here, since this is the first order differential equation, therefore we place as 1. Suppose we are having d square y of t, then here we will take the value of n as 2. Since it is a first order differential equation, we will take the value of n as 1. Therefore, we can find the obtain the characteristic equation, that is obtain the roots. We can obtain the roots of a characteristic equation by using this formula, that is summation equal to k equal to 1 ak r raised to k equal to 0. Therefore, elaborate this summation, that is place the value of k is 0 here. Therefore, this becomes a0 r raised to 0. R raised to 0, anything raised to 0 is 1 only. Therefore, we will get what in place of a0. Then plus, now we will substitute the value of k as 1. Then we will get a1 r raised to 1. That this is nothing but r1. 1 r raised to 1 is only r only. Then we have obtained, when we elaborate this summation equation, we will get that is nothing but it is equal to a0 plus a1 r1 equal to 0. Therefore, from equation 3.2.7 here, from equation 3.27 we have a0 equal to, compare this equation from this to this equation 3.27. From this will come, these are nothing but this is the coefficient a, this is a0, this is your a1. Therefore, here compare from equation 3.27 we have a0 equal to 2, a0 equal to 2, and a1 equal to 10. These are nothing but the constants, that is nothing but a0 and a1. Therefore, substituting those values in the above in this equation, then that is nothing but a0 equal to a1 is equal to 10. Substitute those values in this equation, we will get 2 plus 10 r1 equal to 0. Therefore, r1 is equal to when 2 comes this side, then it will minus 2, and this 10 comes in the denominator, then we'll get the value of r1 as minus 0.2. Then what happens? Then what we'll do? That is next step. In next step to obtain form of natural response. To obtain the form of natural response, this is since the root of the characteristic equation is real, that is the output, the natural response output is equal to y raised to n y raised to of n of t equal to c1 e raised to r 1 et. Since here value of n is 1, therefore here while finding here in this equation, here this is the equation. Here in this equation, substitute that values. From that will come to know that we'll get the value as like this. This is the obtain the form of natural response y raised to n equal to this. Putting the value of r1 in our equation, already we found out the value of the r1. We'll place that r1 value in this above equation. We'll get c1 equal to e raised to minus 0.2 t. You will get, this is our equation of r1. This equation is what? Y raised to n equal to c1 e raised to r1 t. Then here in r1t, here this is r1t. Here what is the value of r1? R1 is nothing but, here this is the value of r1 here. R1 is what? minus 0.2. Therefore, substitute the value of that value in this equation, then it will be y raised to n t equal to c1 e raised to c1 into e raised to minus 0.2. R1 value, substitute the value of R1 as minus 0.2. This equation becomes like this. But since we don't know the value of C1, we'll find out the value of that C1 also. To obtain values of constants in y raised to n of t, therefore we have to find out what is the value of C1. Therefore, the initial condition is y of 0, putting t equal to 0 in the above equation. Here already the problem they have given, that is here with y of 0 equal to 2. In the problem they have given, this is the input, and with y of 0 is equal to 2. Therefore, to find out that one, what we'll do, we'll place the y, we will find out the initial condition y of 0 equal to, putting the value of t as 0 in our equation, then we'll get y raised to n equal to 0. Then it is equal, when it is equal to 0, then t is equal to 0. Here we have placed the value of t as 0. Here 0 means total term becomes 0. E raised to 0, 0 to 0 is nothing but 1. Therefore we have got only c1 y raised to 0 equal to c1, because this complete term becomes 1. Therefore y t equal to 0 means total term becomes 0. E raised to 0 is nothing but 1. Therefore this is equal to y of 0 equal to c1. Already in the initial condition only they have given, that is y of 0 equal to 2. Therefore y of y raised to n is equal to c1. Therefore what is this? Y raised to n is 2. Therefore 2 equal to c1. Therefore since y raised to 0 equal to y raised to n equal to 0, since therefore what is the value of c1? That is 2. Therefore in the our equation, substitute the value of c1 here. Hence the equation 3.2.9, this is what equation 3.2.9. This equation substitute the value of c1 here, then the result will be y raised to n equal to, in place of c1 substitute 2 equal to 2 into e raised to minus 0.2 t. This is nothing but this is the natural response of a given system. This is how we can find out how we'll find out how we'll obtain the natural response of a differential equation when they are given such problem. Okay, next video lecture we'll discuss, that is how we'll obtain the forced response. This is about natural response. Next, with an example, we'll discuss about how we'll obtain the forced response of a differential equation. Okay, thank you.